Have you ever wondered how a nuclear missile can travel from one side of the planet to the other and still hit its target with terrifying accuracy without using GPS? This is not just a rocket flying through the sky. This is one of the most advanced, most secretive technology. A machine designed to find a target anywhere on Earth and destroy it in minutes. Back in the 1950s, accuracy was nowhere near as precise. Some could miss by kilometers. That meant if you wanted to guarantee destruction, the solution was simple: make the warhead bigger. But today, delivery systems have become so advanced that some modern missiles can strike with incredible precision. How does a missile know where it is? An ICBM stands for Intercontinental Ballistic Missile. These are long-range missiles designed to travel more than 5,500 kilometers, often carrying nuclear warheads. Unlike an aircraft, an ICBM does not simply fly all the way to its target. Instead, it follows something called a ballistic trajectory. Think of it like firing a bullet, but on a planetary scale. In the first stage, the missile's engines push it upward at enormous speed. Once the fuel is gone, the missile continues toward the edge of space, and then gravity takes over. It follows a calculated path through space. By the time the warhead re-enters the atmosphere, it can be traveling at several kilometers per second. It reaches its target in roughly 20 minutes. The origins of this technology go back to World War II. Nazi Germany first developed the V-1 flying bomb, which could fly toward a target, but it could be shot down. So German engineers, including Wernher von Braun, developed something far more dangerous, the V-2 rocket. Inside that weapon was the beginning of the guidance technology that would later shape modern missile systems. It must navigate by itself. Why? Because in a real war, radio signals can be jammed. GPS signals can be blocked or destroyed. The missile must be independent. That's where this comes in. INS Inertial Navigation System. It uses gyroscopes to measure rotation and orientation, and accelerometers to measure speed. The onboard computer constantly calculates where the missile started, how fast it is moving, and how far it has traveled. It is tracking itself. But a rocket shakes violently. It experiences extreme forces. So how do the sensors stay accurate? The answer is a gimbal-stabilized platform. This system uses rotating rings to keep a platform stable. This was the key technology behind early missile guidance and even the Apollo missions. Over thousands of kilometers, even a tiny error becomes a huge miss, so engineers came up with a backup solution: stellar navigation. Some missile systems literally use the stars. Onboard sensors could compare star patterns with stored star maps to correct the path. The most advanced weapons ever built were navigating like ancient sailors, except instead of crossing oceans, they were crossing continents. Later, engineers developed ring laser gyros. These use light instead of spinning metal. Laser beams are sent in opposite directions. This tiny difference allows the system to measure rotation with incredible precision. Fewer moving parts, less drift, and far greater reliability. Then came the most frightening upgrade, MIRV. A single missile can carry multiple warheads that can separate and head toward different targets. Stopping just one incoming missile is no longer simple. Why wouldn't the missile just use GPS? Because GPS can be attacked during war. For a strategic weapon, that is unacceptable. The deadliest weapons are designed to operate, even when everything else fails. The evolution of ballistic missile technology is an extraordinary achievement in engineering, but it is also one of the darkest. Every improvement was built for one purpose: to strike anywhere on Earth, fast, and with devastating force. It is a terrifying reminder that some of humanity's greatest inventions were created not to save lives, but to end them. If you want more about hidden military technology, subscribe now. Tell me, do you think this technology protects the world or puts it in danger?